Lecture 4, Thickness and Depth. Thickness, T, is the perpendicular distance between the parallel planes bounding a tabular body, for example a sedimentary layer. This is also called true or stratigraphic thickness. Apparent thickness, T', is the distance between the bounding planes measured in some other direction. This is always greater than the true thickness. Outcrop width, W, is the distance perpendicular to strike between the traces of the bounding planes measured at the surface, on horizontal or sloping ground. And depth, D, is the vertical distance from a specified level, normally the ground surface, down to a point, line, or plane. Stratigraphic thickness can be measured directly in the field as illustrated here. The upper figures A and B are for horizontal and vertical layers. We can also use an instrument to measure thickness. This is called the Jacob's staff, and it is a stick of known length with a clinometer at one end. To measure the thickness of a series of beds, we need to incline the stick such that our line of vision along the top end of the stick is parallel to the dip direction, and the clinometer marks the dip. This is illustrated by figures A and B at the bottom. The thickness between the top of the beds, the red point in figure B, and the base of the beds, the feet of the observer, is equal to the stick's length. We can do this repeatedly to determine the thickness of a thicker sequence of beds as illustrated in figure C. The black line in that figure shows the path and the number of stick measurements taken to determine the thickness of the beds. We can also determine the thickness of a layer indirectly, using trigonometry. Here is the simplest case. Measuring the thickness of a layer on a horizontal traverse. If the traverse from the base to the top of the layer is perpendicular to the strike direction, we use the first equation, where W is the length of the traverse. If the traverse is oblique to the strike direction, we use the second equation, where L is the length of the traverse. Delta is the dip of the layer, and beta is the angle the traverse makes with the strike of the layer. The calculation becomes more complicated if the traverse is along sloping ground. For the traverse perpendicular to the strike direction, these figures summarize all possible situations. All these situations boil down to this equation, where if the slope, sigma, and dip of the layer, delta, are in opposite directions, one must use the sum of them, while if they are in the same direction, one must use the difference of them. In this equation, W is the length of the traverse. This is the thickness formula for the most general situation, a traverse AC on sloping ground and oblique to the strike direction. In this case, the thickness is a function of the length of the traverse, L, the slope of the ground, sigma, the direction of the traverse with respect to strike, beta, and the dip of the layer, delta. If the slope of the ground and dip of the layer are in opposite directions, you should use the sum, and if they are in the same direction, you should use the difference. Finally, this figure shows how to determine true thickness, T, from the apparent thickness measured on a well. The angular departure of the well from the vertical is called the drift, psi. The left figure is for a vertical well and zero drift. In this case, we use this equation. T'V is the apparent thickness of the layer along the well and delta is the dip of the layer. The middle figure is for a well drifting down dip. In this case, we use this equation. T'M is the apparent thickness of the layer along the well, delta is the dip of the layer, and psi is the drift. And the right figure is for a well drifting up dip. In this case, we use this equation. The formulas in this lecture are handy, but they are difficult to remember and can be confusing. In the next lecture, we will look at a simpler and more elegant way to compute the thickness of a bed using linear algebra. To learn more about this part, read these sections in Reagan. And answer these questions.